Hey there, science fans. Today we're diving into the exciting world of apple farming, where technology is transforming how we grow this delicious and nutritious fruit. Picture this, drones soaring over sprawling orchards, their cameras capturing every detail of the trees below. This isn't a scene from a sci-fi movie, it's the future of agriculture. Our project aims to revolutionize apple farming by harnessing cutting-edge technologies like drones, the Internet of Things, and artificial intelligence. By combining these powerful tools, we can help farmers make smarter decisions, optimize resource allocation, and ultimately grow healthier and more abundant apple crops. Imagine a world where every apple tree gets the personalized care it needs to thrive. That's the vision driving our work. This project isn't just about increasing yield, it's about sustainability. By using resources more efficiently, we can minimize the environmental impact of apple farming and ensure that future generations can enjoy the fruits of our labor. Now let's explore the amazing technologies making this vision a reality. So what exactly are these high-tech tools that are transforming apple orchards into smart farms? Let's break them down. First up, we have drones, also known as unmanned aerial vehicles. These flying robots are equipped with high-resolution cameras that can capture incredibly detailed images of the orchard from above. Think of them as the eyes in the sky, providing farmers with a bird's-eye view of their crops. Next, we have the Raspberry Pi, a tiny but mighty computer that acts as the brain of our system. This credit card-sized device collects and processes data from various sensors, making sense of all the information flowing from the orchard. To connect all these devices, we're using LoRa, a long-range, low-power communication technology perfect for covering vast agricultural areas. LoRa allows our sensors and the Raspberry Pi to talk to each other wirelessly, even over long distances. Finally, we're using convolutional neural networks, a powerful type of AI, to analyze the images captured by our drones. CNNs are like super-powered image recognition systems that can identify patterns and anomalies in images, helping us assess the health and vitality of each apple tree. Let's zoom in on the crucial role of drones in our smart orchard. Equipped with high-resolution cameras, these aerial scouts capture images that reveal a wealth of information about the trees below. We're not talking about your average smartphone snapshots here. These images are detailed enough to spot individual leaves and even detect subtle changes in leaf color. Why is this level of detail so important? Well, by analyzing these images, we can identify early signs of stress or disease in apple trees. For example, a slight yellowing of leaves that might not be noticeable to the human eye could indicate a nutrient deficiency or the early stages of a fungal infection. Catching these issues early is crucial for effective treatment and can prevent widespread damage to the orchard. But it's not just about spotting problems. Drone imagery also helps us understand how individual trees are growing and responding to different conditions. This information allows farmers to optimize irrigation and fertilization, ensuring that each tree gets exactly what it needs to thrive. Section 4. LoRa bridging the gap between orchards and insights. Now imagine you're a farmer with a sprawling orchard spanning acres of land. How do you get all that valuable data from your drones and sensors back to your computer where it can be analyzed and put to good use? That's where LoRa comes in. LoRa stands for long range, low power, and it's a wireless communication technology perfect for connecting devices over long distances while using minimal energy. Think of it as a walkie-talkie system for your orchard, allowing sensors to send data to a central hub, even if they're hundreds of meters apart. This is especially important in rural areas where cellular coverage might be spotty or unavailable. LoRa's low-power nature means that sensors can run for months or even years on a single battery, making it a cost-effective and sustainable solution for large-scale deployments. With LoRa, our smart orchard can stay connected, sending a steady stream of data back to the Raspberry Pi for analysis. Section 5. Sensing the secrets of the soil. While drones provide a bird's-eye view, we also need to understand what's happening beneath the surface. That's where our network of LoRa-enabled sensors comes in, strategically placed throughout the orchard to monitor crucial soil and climate parameters. These sensors act like underground detectives, constantly measuring factors like soil moisture, temperature, pH levels, and even sunlight intensity. This real-time data is like gold for farmers, providing invaluable insights into the growing conditions experienced by each tree. For example, if soil moisture levels drop below a certain threshold, the system can alert the farmer to irrigate that specific area, preventing water stress and optimizing water usage. Similarly, by monitoring sunlight intensity, we can identify areas of the orchard that might be receiving too much or too little shade. This information can guide pruning decisions, ensuring that each tree gets the right amount of sunlight for optimal growth and fruit production. Pause 3S, Section 6, the power of NDVI and economic impact. NDVI, or Normalized Difference Vegetation Index, is crucial for farmers. It uses satellite imagery to measure plant health by analyzing light reflection. This helps identify thriving areas and those needing attention. NDVI aids in decisions about irrigation, fertilization, and pest control. Pause 2S. Now let's look at the economic impact. Leveraging NDVI and soil sensors increased productivity and profitability. This data-driven approach led to a 15% GDP growth. Pause 3S. The future looks promising for farmers worldwide.